Okay, good evening, everyone. Mr. Lau here. So today I'll be covering through the topic of inequalities. Okay, inequalities itself is actually a very important chapter, especially for those who are eager to enter the tertiary education. Okay, in fact, in universities, even for higher level, postgrad, masters, PhD, okay, we are actually no longer concerned with solving equations. What we are more interested in is actually solving for inequalities because inequalities actually gives us the boundary of our solution. Okay, because exact solutions are no longer important or no longer even possible at high levels. Okay, what we are more interested in is where does my solution actually lies, or what is the probability of my solution actually gonna be if it lies in a particular section. Okay, is particularly useful for areas like AI, for computing, or even for optimization of various networks. Okay, it can be a simple solution to a traffic problem or even a air control problem. Okay, Ken. So, but having said that, those are more advanced topics. We will always begin with the most fundamental. Okay, which is to solve for these inequalities. Okay, we have touched and covered this topic before in secondary school. Okay, Ken. So over here, what we want to do is we want to improve our understanding on it and actually try to gain more understanding in solving inequalities itself. Okay, it's not just a mathematical equation, but we hope to find some meaning towards it. Okay, Ken. So without further ado, let's begin with these inequalities. So the first thing that I'm actually going to talk about is actually to solve the inequalities using an algebraic method. So this is a very common method, okay, that we have actually seen in secondary school. Okay, let me just open up my pen. Okay, so we want to solve for inequalities using the algebraic method. Okay, so what is this method about? I think most of us are very familiar with it. We will just use a simple example, okay, to actually recap the procedure. Okay, so let's start with this. So the first step is actually to shift everything to the left hand side. Okay, so over here we will shift my 4x square and my minus x to the left hand side. All right, so we end ourselves with this equation. Okay, then on the left hand side, okay, we will try our best to factorize. Okay, so in this case, firstly, what we can do is we can take out the x. Okay, take out the x. Okay, and the remaining will be x squared minus 4x minus 1. So x squared minus 4x minus 1, there's actually two ways we can factorize it. Of course, before we actually talk about factorizing this, okay, the more intelligent way is actually to press your calculator first to check if there's roots. Okay, so if let's say there's no roots, then actually this equation is not factorizable at all. All right, but if there's roots, then probably it's factorizable. Just a matter of whether the roots are nice or not nice. Nice meaning probably an integer value, not nice meaning some recurring decimal place or some fraction. Okay, so in this case, there is indeed roots if you press your calculator. So there's actually two ways to solve for the roots if you want to obtain an exact value. Okay, so in JC, what we are concerned with, or in A levels, we're concerned with actually exact value. So we cannot just press the calculator and pump in the value because it's not exactly exact. So to get the exact value, all right, we can either use our this one, okay, which is our x is equals to b squared minus 4ac, okay, using this traditional method, okay, to get the exact value. So in this case, if I put in the coefficient, I will get two roots, which is 2 plus minus root 3. Okay, can. So this is one of the common methods that most people will use. Alternatively, let me just erase this. Okay, alternatively, okay, there's actually a very neat way. Okay, so I'm just going to quickly demonstrate to you over here. So if I start off with x squared minus 4x minus 1, okay, what I can do is I can do a simple complete the square. So in this case, it's x minus 2 square minus 4 minus 1. Okay, can. So in this case, this will be x minus 2 square minus 5. Okay, just let me double check. X square minus 1. Okay, can. So with that, we can actually uh, do a factorization from here. So what are we going to factorize over here? We're going to change it into this form, x minus 2 square minus root 5 square. So if you recall, okay, recall the formula over here is a square minus b square. So if I use this formula, this will be x minus 2 minus root 5 times x minus 2 plus root 5. Okay, can. So we can actually factorize using this method. Okay, I think having said that, maybe there's an error in the notes. This over here should be 5. Okay, this over here should be 5. Just to double confirm, I think, yep, that should be 5. Yes. Okay, there's a typo there, that should be 5. Okay, so either you can use your x equals to minus b plus minus b squared minus 4ac over 2a to factorize it, or you can use this method, which I find it quite neat lah. Okay, of course, but you need to do your complete the square first. Okay, can. So let me just clear everything. So once I factorize, okay, I'll get this part over here. Okay, so the next thing we're going to do is draw a number line to put in the roots. So the number line over here, okay, so the roots wise, okay, we have 3 roots over here, starting with 0 being the smallest, okay, followed by 2 minus root 5, and then 2 plus root 5. Okay, can maybe just let me double check the value for root 5, since there's a error in that. Okay, so actually, wait, I can't use this same number line anymore, because the value has changed. It's no longer root 3. Okay, so let me just clear all drawings again. So again, so this is root 5. Okay, so if I have the 3 roots, okay, you'll start off with 2 minus root 5. Okay, in the middle will be 0. Okay, then this will be 2 plus root 5. Okay, can. So what we're going to do here is we're going to test the region. Okay, a lot of you from secondary school, actually, to test the region, basically you will draw the graph over here. Correct. So if you draw the graph, it will look something like this. Okay, can. So actually, there is a more simple way that I like to do this. Okay, which is to test the region, or the sign of each region. So let's say in this region, okay, this value over here, okay, what we are concerned with is the value of x times x minus 2 minus root 5 times x minus 2 plus root 5. Okay, so for this particular region, okay, I can choose a test value. So for example, if I let x be equals to 10, so this will be 10 times 10 minus 2 minus root 5 and 10 minus 2 plus root 5. And this value, this, if I compute it, which I'm not going to compute, it's going to be a positive. So having said that, to me, this is actually the positive region. Okay, I can choose any value that is greater than 2 plus root 5. So today I just choose a convenient one, which is x equals to 10. If I sub into the expression, it gives me a positive value. So you can do the same for the other regions. You realize that this is negative, this is positive, and then this is also negative. Okay, so this thing actually is is something you're already known, because this actually corresponds to the graph that you actually drawn. This is the graph that you drawn. This is actually positive, correct? The first part is positive. It's above the so-called x-axis. This here is negative, then followed by positive, then by negative. Okay, so you can choose, feel free to choose any other method that you want, or out of these two, you can choose any method that you want. But to me, to find more purpose or more reason in doing this, it's better for me to put in a test value, because this tells me that this is a positive region. Okay, I don't want to just memorize or just draw the curve. Then I know that anything above it, I need it, or anything below it, I need it. Okay, can. So the final step, okay, is to look at your sign behind. You want this expression to be less than 0. Okay, less than 0 means that you want only the negative region. Okay, so negative region, the solution will be x less than 2 minus root 5, or x between 0 and 2 plus root 5. Okay, so this will be my final solution. Okay, take note, I'll discuss more about the use of or. Okay, over here in our solution for now, we'll always use the word or. Okay, no matter what. Okay, you just need to bear in mind one thing. For the final expression in your exam, it must contain the word or. You can never use the word and. If you use the word and, means that you have not simplified the solution enough. It must always be or. Okay, so for this case, I will take the values of x either in this region or this region. Okay, Ken. So just to have a quick recap, it's a very simple to solve inequalities using algebraic method. Firstly, first step number 1, we try to shift everything to the left-hand side. Step number 2, we try to simplify by factorizing. Okay, and any quadratics, please try to factorize. Okay, Ken. So finally, draw your number line and then write down the solution based on the region that you want. Okay, so these are some of the steps that we already know, and I think most of you should be very familiar with. Okay, so there's a few points that I want to make over here, which is A, B, and C over here. So let's look at it. So point number A, when multiplying by a negative sign, okay, the direction of the inequality or the crocodile mouth must be swapped. Okay, so I think this one most of you should know lah. So if let's say it started off with minus x more than 3, if I want to swap the negative sign around, okay, I need to switch the inequality sign. Okay, so from this step to this step, okay, actually the main mathematics behind it is actually to multiply negative throughout. Okay, it's not just about just shifting the negative to the other side. Okay, some of the secondary school teachers, when they teach, oh, I shift the negative to the other side. So the moment you shift it, you change to crocodile mouth. Actually, the true mathematics behind it is actually to multiply the negative throughout. Okay, so whenever you multiply negative throughout your whole entire inequality, the inequality sign must swap. Okay, next B. Okay, what do? If let's say you inverse the inequality, the direction of the crocodile mouth must also be swapped. So for example, if I start with 1 over x more than 2, okay, if I invert it, so it becomes x and half, okay, then I must also change the inequality sign, okay, to the other side. Can? Okay, so this A and B, I think most of you are very familiar with it. Okay, so just make sure you remember to do it in the exam. Okay, lastly, for C. C is actually very important. Okay, I know a lot of your teachers in secondary school say that cross multiplication is not allowed for inequalities. Okay, there is a reason why the secondary school teachers like to say that. Okay, particularly is because they don't want the students to be confused. They just want to give a simple rule of thumb to follow, and if you follow it, probably you'll get it correct. Okay, but the actual reason behind it is because we are not allowed to cross multiply if we do not know the value itself. if we do not know the value itself. Okay, so what do I mean by if I do not know the value itself? So you mean that cross multiplication is allowed? Yes, cross multiplication is allowed. So for example, okay, using this one over here, 1 over x more than 2. Okay, so we are told not to do this. If I want to cross multiply 1 and 2x. Okay, yes, this is not allowed. Why? Because we do not know what is x. X is an unknown value. X can be positive or x can be negative. So there's ambiguity here, which brings us back to point number A. Because if x were to be negative, all right, and I cross multiply it, I'm supposed to swap the inequality sign. So this is not allowed. Okay, but what if I have this case over here, the other case? The other case over here, x over 2 more than x squared over 3. Okay, so can I actually cross multiply? Can I bring the 3 to the left hand side and 2 to the right hand side? The answer is yes. Why? Okay, because what we are doing actually here is we are multiplying 3 and multiplying 2 throughout. And 3 and 2 are known positive values. So if I know the value itself, I can bring the 3 over and 2 over. Of course, it's not per se bring over, it's just multiplying throughout. Same concept, I just know the negative. When I want to eliminate something, I need to multiply it throughout the inequality. So this is okay because we know that we are multiplying 3 and we are multiplying 2, and these are positive definite values. Therefore, it's possible. Let me give another example. Okay, another example, okay, will be, let's say I have 1 over x squared more than 2. So now the question is, can I cross multiply? Or to be exact, can I multiply x squared throughout? If I do that, I'll get 1 more than 2x squared. The answer is yes. Why? Because once again, we know that x squared is positive. So the idea I'm trying to bring across over here is multiplying throughout. Don't talk about cross multiplication. Okay, cross multiplication honestly don't really apply to uh, inequalities. What we are actually doing is multiplying throughout. So multiplying throughout is possible if we know the value itself. If we confirm that that certain thing is actually positive. This is a very strong point that I want to make because it will help you to simplify a lot of things in the exam. It provides a shortcut. You don't have to shift things here and there and then trying to make common denominator and stuff. It's going to waste a lot of time. Okay? And so hopefully you get my point here. I can multiplying stuff throughout if I know that the value is positive definite. Okay, Ken, so that's all for this part. Okay, so what are the cases that we can see in the exams? Okay, so the first case that we can commonly see is inequalities with factorizable quadratics. Okay, factorizable quadratics means I can factorize the stuff. So let's try with this example. Okay, so same thing, using the same method, I have to shift everything to the left hand side. Okay, practicing what I preach. Shift everything to the left hand side. Okay, then I try to factorize. In this case, if you can see the factorization, a neat factorization I can do here is I first factorize out the first part. Okay, and then I can bring out the common factor of x plus 5. So here we'll be left with x minus 5 minus x squared plus 3x plus 1. Okay, can. So from here, if I simplify, okay, this will give me x plus 5, and this will be minus x squared plus 4x minus 4, more than 0. Okay, let me remove the minus by multiplying minus throughout. So this is x squared minus 4x plus 4. Swap the inequality sign. So I'll get x plus 5, continue to factorize. Whenever I can factorize, I'll factorize. So this is this. Okay, so x plus 5 times x minus 2 square, less than or equals 0. So again, I'm going to try to make an important point over here. Okay, what we are actually trying to do for inequalities is I want to know the values of x for which this freaking expression is less than 0. So what does it mean? I want to find the values of x that will make this whole expression or this entire expression less than 0. If we see over here, this x minus 2 square is always positive because of the square there. So can I then say that in order for the whole thing to be negative, x plus 5 itself must be negative? Okay, so over here, what we are trying to do is we want to use some common sense and logic. We are not just trying to solve this mathematically, no. Follow the step, draw the number line, get the answer. No, we want to look at it on the left-hand side. We want this expression to be less than 0. So for that to happen, okay, and we have this x minus 2 square. This is always positive. So therefore, we can say that x plus 5 must be less than or equal to 0. So we can do this simplification. Don't do it blindly. Simplify. And the answer here will be x less than or equals to minus 5. Okay, but are we done? Essentially, we actually tried to omit this part. But will this part take a role in forming the equation? The answer, unfortunately, is yes, because of this equal sign here. Because a possible solution for this on the other side is x equals to 2. So there is still something that we can extract from here. Because if x equals to 2, it makes this part here, x minus 2, 0. And it also makes the overall expression 0. So we don't just omit this entirely. We need to observe. In this case, we also accept solutions whereby this inequality is also equals to 0. So if it's also equals to 0, x equals to 2 is also a possible solution. So the final answer will be x less than or equals to minus 5 or x equals to 2. Okay, can. So that's all for this example with factorizable quadratics. Whenever possible, factorize as much as you can, then solve for it. Okay, can. So let me just erase this part. Do this. Okay, how about the 1.2? 1.2 inequalities with non-factorizable quadratics. So what if I have certain things that cannot be factorized? So I have this simple inequality over here. Everything has been shifted to the left-hand side. Okay, everything has been shifted to the left-hand side. So, however, we still have a quadratic here. We try to factorize it. So the first thing, as I mentioned, press your calculator. Press calculator. Check first. Can there be roots or not? In this case, the answer is no. If there's no roots, means you cannot factorize it. Then what should we do? Okay, so what should we do in the exam? Okay, we should consider, okay, this is the proper way of writing, x squared minus 3x plus 4. And I'm going to do a complete the square. And when I do this complete the square, you realize that this expression is positive definite. How come it's positive definite? Because this part here is positive, and this part here, if you add it up, is also positive. Therefore, the overall expression is positive. So we know that, again, this expression over here is positive. So once it's positive, it doesn't play any role in the inequality, at least for now. So in order for the entire thing, to be, the entire expression to be less than or equals to 0, if I know that this is positive, so what I'm going to write here is x plus 1, x minus 2 must be positive. I can simply ignore the first part just by logic. Okay, draw a number line. Minus 1, 2, plus, minus, plus. You want a positive region, so you'll be x more than or equals to 2, or x less than or equals to minus 1. Okay? So this is our answer. So again, we need to check back again. Does this expression contribute to the equal sign? Because there is an equal sign here, right? It can be equal to 0. So there's no way for this thing to be equal to 0. Okay, you can't find an x value that gives us 0. So we can, in this case, completely ignore it because it doesn't contribute to the 0 answer. Okay, can? So that's it for quadratics with non-factorizable. Non-factorizable, very simple to deal with it. What we need to do is to complete the square, prove that it is always positive, and then you can take it out from your inequality. But please bear in mind, we still need to check back again, does it contribute to the equal 0 solution? Okay. Okay, let's move to the next page. Okay, so the other thing that is commonly tested in JC, okay, is actually inequalities containing rational function. Okay, so rational function means I have something in the denominator and I have something in the numerator. Okay. Oops. Let me just. Okay. So I have something in the denominator and something in the numerator. Okay. Can. So if you want, you can actually rewrite it into this way. Okay. Can. So this form of expression is acceptable if you multiply the left hand side by x minus c square and you multiply the right hand side by x minus c square. Okay, so the right hand side will be 0. The left hand side, the square and the x minus c will cancel and it gives you the left hand side expression. Okay, can. So there's two choices. Either you can leave it like this after you factorize, or you can rewrite it into this. Either way is fine. Okay, so let's go through this block test question from Hua Chong. Okay, so the first part here, we have to solve this inequality algebraically. Okay, Take note, what we are doing here is we are still trying to solve things algebraically. There's another part, which is to solve it graphically. So how do we solve it algebraically? Okay, so very standard. All we're going to do is, I'm going to write down the expression first. X squared plus 4x plus 4 over 2x3 minus 5x squared minus 3x. So since everything is already on the left-hand side, I will try to factorize it as much as possible. So the top part will be x plus 2 squared over the bottom part. Okay, what I can do is I can take out the x first. If I take out the x, it will be 2x squared minus 5x minus 3. All right, and then we can continue to factorize it to be 2x plus 1 and x minus 3. Okay, can. So once we are at this step, okay, same thing. Or what we can write here is since x plus 2 square is positive definite. Okay, so since it is positive definite, so the only thing that we need to analyze is the denominator. So again, using the same logic, we want the whole thing to be more than or equal to 0. And today we already know that the numerator is positive. So if I want the entire thing to be positive, then just means to say that the denominator must also be positive. Okay, take note, denominator cannot be equal to 0. Huh? So we only put it as more than 0. Okay, draw a number line. 3 roots in this case. Okay, we have minus half, 0, and 3. Okay, so this will be positive, negative, positive, negative. Or you can draw it this way. Up to you. Okay, so the solution, I want it to be in the positive region. So x must be between minus half and 0, or x must be more than 3. Okay, can. But take note, okay, if you write like this in the exam, you will be minus 1 mark. Why? Because you are still short of one part. As I say, repeat myself again, even though I omitted this, I need to check whether it contributes to the equals to 0. So in this case, yes, or x is equals to minus 2. Okay, can. So in this case, this is my full solution. Okay, let's look at the next part. Hence, find the range of values of theta for which this one, this expression, okay, over here, is more than 0. So this kind of question, very simple. We are supposed to determine a substitution that brings us from here to here. Okay, I'm not going to prove the substitution to you because it's actually quite easily seen. Okay, the substitution that you can use here is to replace x with cosine theta. When you got time, you can do it yourself, prove it yourself. Okay, so cosine theta, so if cosine theta can bring this expression to the final expression that you want, so the cosine theta expression can also be applied to the solution. Okay, so let's apply it. So it'll be minus half cosine theta or cosine theta more than 3 or cosine theta is equals to minus 2. So now we have come to another area of inequalities. Inequalities involving trigonometry. From secondary school days, we know that trigonometry is difficult to deal with because of its cyclic nature. The solutions repeat themselves for given theta. So I'm here going to say this once and for all. The best way to deal with inequalities that have trigonometry is to draw the trigonometry graph itself. In this case, we'll draw the graph of cosine theta. we are going to draw it specifically for the range of values between 0 and pi. So how does it look like? It's going to look fairly simple. It's going to look like this. This is 0. This is pi. Okay. So now let's put in the range of values that we need. Okay. So I want the range for cosine theta is between -half and 0. I want the y value of cosine theta to be between -half and 0. So -half is going to be somewhere here. So I'm going to trace it, take the cosine inverse, and I can clearly see that this is 2 pi over 3. And 0 will just be here. So for the first, it will be this region. For the y value to be between -half and 0, theta must be between, this is pi over 2, in case you don't know, pi over 2 and 2 pi over 3. Okay, can. So this is 1, this is -1. So for the first part, we got the answer. Between pi over 2 and 2 pi over 3. How about for the second one? How about for this one? This provides us with an invalid inequality. Why? Because if you can see it from the graph, cosine theta can never go beyond the value 1. So why do you even need to talk about going beyond the value 3? Invalid. Same thing, cosine theta can never be -2. So invalid. Okay, so the final answer for this just be pi theta must be between pi over 2 and 2 pi over 3. Okay, so when it comes to solving inequalities with rational function, very simple, same step, factorize everything. Okay, can. And if you want to leave it like this, also can. You want to bring everything up, also can. Okay, most importantly is you must know what you are trying to do. You are trying to solve for the inequality for which this expression is more than 0 for this case. Okay. Okay, let's move on. Okay, one more example over here. Okay, so we have this inequality again without using GC. So let's do it. So we'll start with the first equation, 2x squared minus 3x minus 1 over x squared minus 4x plus 1. So in this case, I need to shift the 1 to the left-hand side. Okay, just a standard step, shift everything to the left-hand side. Try to combine it using the common denominator. Okay, simplify the top expression. Okay, try to factorize wherever I can. Denominator. In this case, it can be factorized, okay, but it will produce a not so nice answer. Okay, but it's okay. Just now I already shown how to do it. So I'm not going to repeat again. Okay, can. Then after that, we can choose to leave it like this. Then we can put in your number line. So in this case, there's altogether 4 roots. Okay, starting with -2, 2 minus root 3, 1, and 2 plus root 3. Put in the test value, x equals to 10, okay, into this expression. And you know this is positive. Then the rest will alternate. Negative, positive, negative, positive. So you want the solution for which it gives the expression less than 0. Okay, so for less than 0, I want this region and this region. So the answer, very simply, x between -2 and 2 minus root 3, or x between 1 and 2 plus root 3. Okay, so that's the answer for the first part. Okay, next, hence solve the inequality for this. So again, we have to determine the substitution. All right, so again, I'm not going to prove to you the substitution. I'm going to tell you what substitution is. We're going to substitute x is equals to negative square root x. Okay, a lot of students will just try root x, but you realize that the sign is different. Okay, so you need to put a negative there. Okay, so since if this substitution will work, means to say that I can perform this substitution to the solution also. Okay, so let me just erase all this. Okay, so it'll be negative root x between -2 and 2 minus root 3, or negative root x between 1 and 2 plus root 3. Okay, so when you come to this part, all right, when you come to this part, actually you can straight away realize something. What can you realize? You realize that this expression here is not going to give you a valid solution. Correct? Why? Because look at the middle part, it's negative root x. Root x is positive. Negative root x is negative. How can a negative number be between 1 and 2 plus root 3? Both of these are positive numbers. So this part has no solution, just by observation alone. So don't go around solving it like secondary school students. Use some logic. Okay, so left with the left hand side, this part. Okay, so the left hand side, what we are going to do is we are going to multiply negative throughout. So if I multiply negative throughout, I could swap the inequality sign. So this will be root 3 minus 2 and 2. Okay, root 3 minus 2 and 2. Okay, swap the inequality sign throughout. All right, so over here, same thing, use your bit of logic. Root 2 minus 2. Root 3 minus 2. Root 3 is around 1.7 something something something. So if you use it to minus 2, it will give you a negative number. But again, this is root x. Okay, root x is always going to be positive. So I can reduce the solution to root x between 0 and 2. Because it is known that root x must be more than 0. I can't take in the lower limit over here. It can be ignored. So to remove the root, square everything. That's it. This is your answer. Simple, nice, and neat. Okay, Ken. So this is for this this part. Okay. Next, we'll move on to 1.4. Okay, but before that, I'll stop this video here first. All right, and I record another part 2.